You are welcome back to the Twitter Think channel. My name is Dan, and in this episode, we will continue from where we ended in our last class. Remember that in our previous class, we spoke of complement rule for conditional probability. It is the series of formulas that we are talking about, so we are continuing from there. So previously, we learned that when two events such as A and B are given to us, and we are told to find the complement of A as the event B has been given. The shortcut formula to solve this is 1 minus the probability of A as B has occurred. We realize that the complement nature or the complementary nature of A complement and A made this formula possible. So go and watch that video, Introduction to Conditional Probability Part 2. Okay, so it is there. I've proven it for you to understand. Now, in today's video, we are moving on to what if the complement is rather for B. So we are giving something like A giving B complement. As B complement has occurred, what is going to be our answer? Is it also going to be similar like this? Let's find out. From the very beginning in conditional probability part 1, we learned that if the probability of A as B has occurred is given to us, we always put it as the probability of A and B occurring together, which is P A intersection B divided by the probability of B, the one we are conditioning on. So using this same idea, we can write this in that same manner as the probability of A intersection B complement divided by the probability of what? B complement, because we are conditioning on what? B. Let's label this equation star. Now, for that one, I told you in that video that the complementary nature of this and this made it possible for us to use this formula. That means we learned that the probability of B, which is P of B, contains this event and this event. So it makes it possible for us to use the probability of A as B has been given. When we subtract it from 1, we should get the answer for this one. When you watch that video, you will understand. But in this state, we cannot use this same process because B complement is a different thing altogether. It's a different subset altogether. The probability of B and the probability of B complement are two separate subsets. Okay, in that case, the probability of A and A complement will be different for these two. All right, with that in mind, then the probability of what? A as B complement has occurred can never be the same for 1 minus what? P of A slash B. If you try to interchange the position of the variable, something like this will happen. Probability of A as B complement has occurred is also not equal to 1 minus probability of B as A complement has occurred. If you try to put it this way, you are also wrong. So how are we going to find the probability of A when we are conditioning on the event what? B complement? Because we cannot use this way, the way we did the first one, to solve this question, we have to concentrate on this formula. So all we need to do is to consider equation star and find A intersection what? B complement. Now, to be able to calculate for probability of A given B complement, we need to start with the probability of A. Now, what is probability of A can give us the probability of A intersection B plus the probability of A intersection what? B complement. So what this means is that the probability of A always contains the members of A and the members of what? B happening together, and the probability of A itself only members of A, because B complement is the same as the members of what? A. Do you understand now? So look at that video, it will help you. So now what we need to do is to make this one the subject. When we do that, we are going to get a probability of A intersection B complement. It's going to give us the probability of A, P of A minus probability of what? A intersection B. So it means that if you don't know A intersection B, this is the way you can find it. So we can put this equation inside equation what? Star, giving us probability of A as the B complement has occurred will give us P of A minus P of A intersection B dividing the probability of what? B complement. So anytime that you are asked to find the probability of the first event given that the complement of the second event has been given, you can use this formula. So if you are given the probability of A, if you know the probability of B complement and you know the probability of A and B occurring, you can solve it. What if you don't know this? And what if you don't know this? Then they will give you the probability of B in the question. So we can say that but probability of what? B complement is equal to 1 minus the probability of what? B. And this is another formula that holds. That will help you to find probability of B complement if the probability of B is given to you. When we substitute this into the formula, then we are having the probability of A given B complement is giving us what? P of A minus P of A intersection B out of 1 minus the probability of what? B. And this formula can also help you to solve for this. Do you understand? The next thing we can do is the event probability of A intersection B are usually given to you in the question. But if they are not given, then we can find it by finding the probability of the event A giving what? B. So now what's something? When we take the probability of the event A as B has been given, remember, not B complement, then it's going to give us what? The probability of A intersection B all divided by the probability of what? B. Remember that we are conditioning on this because this event has been given to us. Looking at the way I've written the variables. Good. So from this analysis, when you divide by 1, you cross multiply. What are you getting? The probability of B multiplies this, giving you what? Probability of A as B has occurred times the probability of what? B, which is equal to P of A intersection what? B. Now, if the question gives you the probability of A given that B has occurred and they give you that value, you can multiply by the probability of B and use it to replace this one. So whatever answer you get here, you use it to. So we can rewrite another equation using what? This. Do you understand? So that can be the third equation, but I think I will leave it here. So you can write the third equation by replacing probability of A intersection B with everything that you have here. Okay, so I'll call it off for this one, but is there any other way that we can solve this that I don't know about? As at the moment, I've not really done much research about it, but if you know any other way we can solve for this, please don't hesitate to solve it or drop it or prove it and drop it in the comment box for other people to also learn. So I'll challenge you to do that. I'll leave that to you to do. You can learn more about. We know we can use other ways to manipulate these equations. Okay. So in the next video, we are going to talk about the probability of A complement given B complement. Remember, these things I can use CC here to represent them. Okay. My name is Dan and I'll see you in the next one.